display switch bridge in the Linux. Initially, I thought that this is a commercial implementation, like it is specific to the particular customer, but based on my customer handling of several of these bridge types, I found out that this can be a generic implementation, can be go into the upstream as well. All these slides I just prepared to understand a little bit in detail, but actual implementation is rather complex, as I explained here. Basically, I work for a consulting company in India, and we have a small team who mainline the open source stuff for the customers who are mainly onto embedded systems. So I was initial maintainer in the U-boot bootloader, and later I have developed many of the drivers related to DRM bridge and panel. So this work is related to those bridges area. To start, very simple. The initial consideration of any bridge, if it can be a converter from one interface to other interface, like it can be a DSI to HDMI or DSI to LVDS, or sometimes it can be a host bridge, like say for example, there is a Samsung DSMI that can be compatible with between different SOCs. So the bridge can be any type. So GPU DRM bridges have both converter bridges as well as host bridges. So far this is fine. So if you have a single input that can be convertible to other output, that is quite easy. But there is a complexity coming into the picture where the one input can be converted into two outputs. But the ideal case would be like you can access only one output at a time. So this is a quite complex bridge, but the hardware itself is simple, but handling this particular stuff is more complex, because there is no hardware intelligence here, because hardware can select by means of whether you want an output of HDMI out or LVDS out. So it's up to the software who wants to deal with all this complexity. To understand this, I have explained all the example of these kind of bridges to little bit more in detail. But this is not like MST, like we have a single display port to multiple streams. This is not something like that. It's a 1-to-n consideration, assuming only one of the output can be accessible at a time. So you can be accessed either HDMI or LVDS at one time. But the main note here, like one of the output of this display should be have HP, like hard pluggable support. Then only you can able to switch runtime. These are the possible switch bridges. The one from the left is like a typical switch where you can see there is a HDMI and LVDS displays. The designer has to implement to make a design using some bridge from Texas Instrument, and he designed several bridges. Like if you say LVDS and HDMI is a different bridge altogether, but selecting those bridges can be part of this PI3W1 MIPI switch. The middle one is something like something more unnatural, like there are two outputs here. One is HDMI out and the other one is projector, like DLP projectors, there where the DSI data can be converted into DMD. So the ideal case of this projector is like the user can see the output in the projector, and if you wanted to switch the output to the HDMI panel, so he can able to switch in runtime. That is the ideal case. And the third case is what is the real IC is all about. Like all the switch things can be done internally, taking care of this particular Logiton LT8912P. So these are three different use cases. So these are the main ideas of my implementation to move further onto the mainstream. This is how like a simple switch looks like. It is quite simple. no complexity at all. There are two GPIO lines, and one is select and another one is output enable. If you want to go HDMI, you need to toggle the select and OU lines, and if you want to go LVDS, you need to untoggle the select and go with output enable. So so based on this switch, the customer can implement ADV 753 bridge, that is for HDMI, and another bridge for LVDS. So this is how the simple MIPI switch look like, but we can see how this can be implemented in Linux. This is a typical DRM bridge looks like. So all the bridges are like a tree fashion. So if you want a bridge A to N, you can even connect bridge A, bridge B, bridge C. So the idea of all these bridges is to attach and detach during runtime, so the pipeline can get access to it, so that the bridges can be go on up to the pipeline decides. The bridge that I'm looking for is a bridge switch, not like a normal DRM bridge, where switch acts as a bridge here. So the input of DSI can be routed, either I can route to the HDMI bridge or it can route to the LVDS bridge. That is how the DRM switch bridge looks like. But the problem is like DRM bridges are not a tree fashion, it's a list. So you cannot access two outputs at a time, or access at rather implement or accessing it at runtime in a tree fashion is not implemented yet. So all these are linked lists, not like a tree list at all. So this is one of the complexity to support this onto existing DRM framework. So the implementation one that I tried, it worked basically, but this implementation does not touch any of the DRM core. I just make all the changes on the bridge switch itself to switch those things into runtime. This is how I implemented. So this is a typical pipeline in MX8M. So the pipeline starts with frame buffer, MXE frame buffer driver. It goes to NWL DSI bridge, and the pipeline goes to display switch. This is where all the switch handlings. From the switch, I have two output endpoints, one for HDMI bridge, and second output is DSI for LVDS bridge. So there are total of 7 bridges. So each bridges can be accessible, like the pipeline will change during runtime by means of display switch, by introducing the HBD interrupt handler basically. So since these are not initialize the runtime at the two different connectors, so only one connector can accessible at a time. So you can able to see only whether HDMI A or LVDS A at runtime. That is how the switch looks like here. If you go further into deep into DRM bridge, this is how the bridge attach will happen. All the bridges are attached in the runtime in a stack mode, like last in first out. Bridges who attach last can get an access to the first. So if HBD off, you can have an access of LVDS. In that case, the bridge list looks like this. But if HBD on, like hot pluggable is on, so the user is attaching some HDMI display. So the bridge chain changed from previous to new one, and then all the bridges will be replaced by the new bridges. Like it can be HDMI connector and ADV bridge, like something like that. The bridge chain is so on changing at runtime up to user is connecting whether he wanted to go with LVDS or HDMI, something like that. Initially I was trying with a simple frame buffer. It worked very well, and I can able to switch the runtime displays. But I found some issues if I go with any of the application like Qt. So what I did was, like, I have used Western Wayland to Compositor. so that it can. The good thing about the Western compositor here is like when I switch to HDMI, it automatically detect the HDMI displays at runtime. So this is the ideal scenario of this situation for me to work is like a KMS and Western flow. So this is how the compositor work at runtime in this fashion. I have captured a simple test to understand how exactly it works. It can be low light, but apologies for those. You can see there is a finger in the down. I'm attaching HDMI. You can see there is a output showing on HDMI display. This is a typical scenario, but entire pipeline gets changed at runtime. This is which is not typically acceptable by Daniel and Maxim in mainline. So they don't want to rebind the bridge at runtime because my initial case was like that, but to understand whether my initial thought was not to touch the DRM framework. So if you touch the DRM framework, then there might be issues with other subsystems. So I rather go with a non-touchable DRM framework and go like the implementation one. So what they suggest, like create another dummy connector and detect those connectors runtime and try to switch them using atomic operations. But that implementation cannot work for me because if I create two encoders and two connectors, the one that attaching in the previous one gets detected as a busy because it's ideally it cannot be a tree fashion. So this implementation cannot work for me. Of course, I need to try rather in the different scenarios. And the other solution that Maxim maintainers suggested to go with a single encoder and try to preserve the previous bit state. But it is not possible to preserve the previous bit state because all the bridges are connected in the list. So this is another difficult issue if I go with the maintainer suggestion. But if you go deeply into the bit switch, maybe you can find some other clues to get into the switching at runtime. But my ideal scenario was like something like this can be initial implementation phase where even we can switch the pipelines for graphics. There is I heard the news that some companies are trying to switch the graphic pipeline at runtime. So maybe this is the initial use case for those scenarios. And those are the main key things from my side. And I'm trying to get into mailing list more often for this to implement to accept in the mainline. And I was trying to work on that particular area. That's it. Thank you. Any questions, let me know.
So in the instance of having two separate bridges connected to the switch, if you can't do a detach, what happens if you have like a different set of flags, say active, high, active, low on one of the parts?
Yeah.
Or you have different numbers of lanes. So you have maybe a 2-lane on one interface, 4-lane on another. How do you intend to address some of those differences on the devices attached to the switch?
The question is like, how can you handle the attach and detach during plugging HDMI cable and unplugging the HDMI cable, right? Yeah, that is how the question is, how can you attach or detach the lanes during runtime while you plug the HDMI cable and unplug the HDMI? To answer that, display switch itself is a bridge. So we have a bridge operations. Right now, what I'm doing, like in the bridge operations, while if user is attaching the HDMI, I find an interrupt. So HPD is on. So if HPD is on, I will try to attach the, I will try to change the bridge chain. So I will change the bridge chain. If the bridge chain is changed, so the DRM bridge will recall again to recollect the bridge. So one of the function is like bridge operations, where you have enable and disable. That is where I'm enabling and disabling the lanes. Yeah.
Can you possibly go back a couple slides? There was, I think, maybe 2 slides. No, that was, yeah. So, when you, I guess, I'll use the word instantiate 2 display bridges there.
Yeah.
Those are same, it's the same device, it's one device, right?
Yes.
You're from a software, from OS perspective, you're treating like a 2 different separate independent devices, right?
Yes.
What do you do with, like, what should I call this, hardware resource arbitration within the device driver when you do that, the top one, not the bottom one, top kind of implementation? How do you handle the arbitration when you have basically 2 different, one is the HDMI, one is the
LVDS.
So they're kind of really not the same type of hardware. So how do you handle the arbitration of that? Basically, essentially, what appears to be, from a software perspective, 2 different independent, stack, right?
Yes.
How do you handle the resource application within the device when you're in that?
Yeah. How can you handle hardware arbitration while switching between these 2 connectors, right? Ideally, even though there are 2 different hardwares, those are connected as separate connectors. From DRM point of view, those are just like connectors. So it is up to the DRM framework to handle those connectors atomic operations, like all these locking systems and everything. So we, from the protocol driver's point of view, we don't need to take care of those things basically. Thank you. That's it. Okay, thanks.